On this problem, this equation, notice we have a minus sign. There's a log property that says, no matter what the base is, that if you have log base m divided by n, that's equal to log base b of m minus log base b of n. It's based on the exponent rules. When you divide, subtract exponents. Same thing going on here. And we're actually going that direction, which means we have two logs being subtracted. We can combine them together using division. So that's what I'm going to do. Take the log 5. Just think of the exponent rules. When you're dividing, subtract. So if you have subtraction, that means you're going to use division. S plus 14 over S plus 6. And that equals log base 5 of S. Now there's another property that says if you have log base b of m, let's just use x, equals log base b of y. Those logs like cancel out. That means that x equals y. That's kind of what's going on here. These logs are like going to cancel out, and it's going to leave us with s plus 14 over s plus 6 equals s. So I'm going to put the s over 1. I like to cross multiply, and that's what I'm going to do. Cross multiply. So we have s plus 14 times 1 equals s plus 6 times s. Now s plus 14 times 1 is just s plus 14, and then s times s is s squared, and 6 times s is 6s. Now since we have a square, that means I need to move everything over to the s squared side, so I have this equal to 0. So I'm going to subtract s, and I'm going to subtract 14. And we get 0 equals s squared, and that's 5s. Let me erase that, make it look better. Minus 14. Now to solve this quadratic equation, you can use the quadratic formula if you want. You can also graph it if you want. You can also factor if you want. I'm just going to use the quadratic formula in this example, which is x equals, it's actually not going to be x in this problem, it's actually going to be s. Negative b plus or minus square root of b squared minus 4ac all over 2a. I really would just rather graph it and not worry about it, to be honest about it, because it's going to be nice numbers I can find really quickly in my calculator. But just to change it up a little bit from previous videos that you may have seen from me, I'm going to throw in my a, which is 1, b is 5, and c is negative 14. So you got 5, 5, 1, negative 14, and 1. So we have negative 5. I like to do the easy stuff first. 2 times 1 is 2, plus or minus. That's 25, and that's plus 56. That's actually 81. If you want to, type it in right quickly. 5 squared minus 4 times 1 times negative 14. I made a mistake somewhere. I made a mistake. What, 1? Is that what I needed? Yeah, there's my 81 that I knew it was there. The square of 81 is a nice number. It's 9. I'm going to go to the right. So we have negative 5 minus 9 over 2, or negative 5 plus 9 over 2. Negative 5 minus 9 is negative 14. Just go on down. You want to? Can't hurt. Negative 14 over 2, or 4 over 2, which is negative 7 or 2. So I have negative 7 or 2 as my possible solutions. Since I have log of negative 7, I can't take the log of a negative number. The 2 was fine because it's positive and I don't have negatives anywhere when I substitute in. But I do get logs of negative numbers when I use the negative 7. So my only answer is x equals 2.